All right. Good afternoon, everyone. This is Xin. I'm from Texas State University. So my topic for today is about exploring the dynamic human mobility of diverse social groups under extremely heat conditions by using a simulated method. So those are the collaborators for this research, and we are also a team that doing research related to natural disaster, spatial accessibility, and human mobility. So here is just some back introduction for this research. As we all know, the global temperature is rising over the last past 10 years. We have experienced the the hottest summer on record, and the heat wave is becoming more frequent and intensive. It impacts the urban areas, suburban areas, and the rural areas. Actually, it affects all the places, on our Mother Earth, and different from other natural disasters like the hurricane or tornado. Heat, especially for the extreme heat, is a silent killer. It can cause the chronic and short-term damage to our human beings. So here, as you can see that this is a project for the global temperature by the end of this century. Almost of the global south area, their temperature gonna be rise a lot. And this is the map for the United States. You can see from the western and also the southwestern areas, it becomes hotter and hotter during the summertime. So given such big impact, and how does that to our human beings for the society impact of the extremely heat conditions? So first, there are so many reasons. For here, I listed three. So the first one is that it causes public health concerns. It will increase heat-related illness and mortality. The second one is it will impact the human mobility and behavior. People might change their daily routine activities during the heat period. The second is that it also will impact our migration pattern. For example, during the COVID, there are so many people there moving from California or New York to Texas. And then after they are experiencing 1 or 2 summers, they decided to move back. One of the reasons is that is because of the long and hot summer. The heat exposure to our human beings, it also has the potential to amplify the equity on heat exposures. The people who has a low income and also the people who has less has less skill, they have less access to resources and have more exposure to heat. Given such impact of the heat wave to our human beings, how can we measure the humans' movement? The previous studies has used the data from American Community Survey or the census data. But such kind of data is static. It is based on the yearly or 5-year or 10 years. And some other researchers, they have using the sample size data, but such kind of data is typically very small and they might be not very representative. So recent years, with the advancement of the technology, especially from the social media, mobile sensors, and GPS, people are using such kind of data to capture the humans' real-time movement. But despite such advancement, there still lack a study to explore the social compositions of the movements for heat exposure assessment. Well, it is very important to explore the social composition of the people who are under the heat exposure, as I have introduced the social impact to our human beings. So it is very important to explore the social composition. So this slide is about the previous method for measuring the proposed social composition of movement. The best way for us to do is that if we can get the individual's information. But the reality is that due to the very strict privacy law in the United States, it's impossible for us to get access to such data, let alone their social composition information. In my previous study, Dr. Ning Lu from University of Cincinnati and we overcame a solution to estimate the social composition, specifically for the race and ethnicity of the people who are on the move. But that study was for the crime. The general idea for that one is if we know the social composition makeup based on the census population, and if we also know where our people are from and where our people go, basically we know their OD flow. And then we assume that the social composition makeup of the people out of their residential areas equals to the social composition makeup of the residential in that area. And then we can use the residential makeup and also the OD flow to estimate the social composition of the ambient population. For that study, for this method, we have apply that to the crime studies. There are two publications that you can take a look at that. Despite, I'm sorry, I have some backup slides to show how about the formula, but I'm more than happy to discuss that during the discussion section. But for here, I just give you an example how this method works. So assume that you can see from the figure here. Assume that we have 5 regions, A, B, C, D, and E. A, B, C, D, they are adjacent, and E is a little bit far away. And within each region, we have a like pie chart, and within each pie chart, for here we have the numbers of the different group of people. For here, we are calculating the race or race group. So we have the blue color for the white, orange color for the black, gray color for the Hispanic, and yellow represents the other races groups. And the area A is the area that we want to calculate the ambient population for each races. And the red flow here represents how many people they are traveling to the region A. So for there are from A to A, which means there are people who have activities in their own region. It's 20 people. B to A is 8 people. C to A is 6 people. D to A is 5, and E to A is 4. And then we just use the formula that we developed in the previous study to calculate the ambient population for the white, for the black, for the Hispanic, and for the other races. And finally, we got the number, determine the number for the ambient population in the area A regarding to different race groups. Despite this is one of the first paper that in criminology that we estimate the social composition for the ambient population, there are still some limitations for this method. Because this method, the ambient population-based method, it only provides a single expected value, and the outcome is a fixed value for each risk group, as you can see from the previous example. And so it does not capture the uncertainty in movement composition. So why this could be a problem? Because our human movement is probabilistic. And different samples of the data can result in different result for the composition, the number of the composition, and the fixed population estimation may misrepresent the actual exposure. So with this issue, we keep in mind, we use the bootstrapping. So in this study, we make a refinement from the ambient population-based method. We provide a new method called the bootstrapping to estimate the social composition with confidence levels. I have some backup slides to show the formula, but I'm more than happy to discuss during the discussion section. But the general idea is that for this method, we simulated the population composition over 10,000 times by rapidly resembling the original areas with replacement. So just kind of like we have a bag, and then there are so many marbles in a bag, and the marbles have different colors. Some marbles they have more quantity, but some others they have less. So each time we take out a marble, and then we put that back. The marbles here for this example is the percentage of the of a specific social composition in the home area. So we do that process and then we can compute the mean proportion of the population composition from the similar set, and then we can get a full distributions of these numerical numbers. It's not just a point estimate from the ambient population-based method. So, and then after this process, we can get a mean value based on the distribution and also get a confidence interval. Why this method is important? Because it captures the randomness in population presence, and it also reflects the range of possible composition. Well, it's not just assumed value. So this is basically the general idea for the simulation method to estimate the social composition based on the human movement. So we use this method to have a case study in the Greater Austin area. So the social composition that we want to discover for this research include the different race and ethnicity, and the young people and the people who has a college degree and above, and the people who only have the high school degree and below. This is a picture for our study area. It's the city of Austin, which is the capital. The skyline is a beautiful city. It's the capital of the state of the Texas. So the cycle is describes roughly the city is located here. So in this study, we include the Greater Austin area, which includes the 3 counties. And the study unit is the census block group. We choose this unit because for the OD data, the finest OD data spatial unit we can achieve is the census block group. The data is from the advent patterns. Before that, it has a formal name of the safe graph. And also, we also retrieve the weather information, such as the temperature, humidity from the Dewey platform. The year for this study is 2019, just right before the COVID, because we don't want our result be co-affected by the COVID pandemic, especially for the lockdown policies. We define the 3 periods. We define them as long, based on the National Weather Service classification. They have a specific form for how can we classify the weather into different heat degree of the heat. The National Weather Service the classification, one of the advantages, different from the ground temperature, one of the advantages is that it is a combination of the humidity and the temperature. So it's a kind of like a perceived temperature that by our human beings. So for here, we use this table we have 3 periods. We define them as the long heat period, caution period, and also the extremely caution period. So the caution period is the period that has a moderate heat conditions. For the extremely caution period, it's heightened heat restraints. Typically, if you look at the manual, if after the calculation, it's like more than 92 Fahrenheit degrees can be defined as the extremely caution period. So those are the partially of our results. So this is basically the general movement across the different social groups that we have. as we can see, is for the general pattern is from the non-heat period to the heat period, the people's movement increase, but from the from the caution period to the extreme caution period, people's movement degrade a lot, decrease a lot. This is a result that we use the CyberJazz platform to visualize our analytic result. So for each combination, you can see three figures. From the left one is a map for the census population for the specific social group accounted for the total census population, and the map in the middle is the movement of a specific group accounted by the total movement, and the plot here describes the patterns between the previous two. One of the obvious things that you can notice for the Hispanic population, there are large percentage of the movement, percentage of the Hispanic movement than the percentage of the census, the Hispanic percentage of the census. But in contrast, for the white people during the extreme caution period, there is less percentage of the movement than that for the percentage of the census population. This is also true for the people who has a high score and below degree. There are more exposure of the people who only have high score and below under the heat exposure than when we compare to the census percentage for the people only who has high score and below. Well, I have more. I have more results on the backup slides. I'm happy to talk to that during the discussion sections. For here, I want to wrap up for my presentation here today. So first, we introduce the monocolor simulated method estimation for the social composition. We fill the gap to assess the social composition of population under heat-related conditions, and we want another point is that we visualize the analytic result for the case of Greater Austin are on the CyberJazz platform, and we in the future we're trying to make it public to the general audience. This is Dr. Han-Soo Yeon gonna be talking more about the CyberJazz Waze platform. How can we use that to visualize our result on June 25? Here is a link for you to register. Well, that's all I have for today. Here is my contact information, and I'm more than happy to take any feedback, comments, or criticism. Thank you so much.